going to do a little bit more work on my solar stereo project. The first thing I'm going to need to do is find a suitable solar panel. Now I'm sure you can find any kind of solar panel that you can get hold of, as long as it's about 5 volts or so would be perfect. This panel is about, I think it's a 160 by 150 millimeter panel. It's rated at 5 volts DC, but it actually produces a little bit more than that under direct sunlight conditions. I just tested it in the sun, got a little bit of direct sun, and I did pick up around about, how much, 250 milliamps. I did a video on both of these modules. They're both PAM something modules. The PAM, what number are they? The 8403. Can't see it on that one. 8403. This one was a 3x3 watts, and this was the 5x5 watts. And I did some testing and decided that this 5x5, 5 plus 5 watts, was the best one. This is also 5 volts. The next thing we'll want for this project is a battery. You could use nickel metal hydrides, I guess, if you want. In that case, your project would be a little bit different. But I'm going for one of these 18650 cells, so 18650s. I believe this is a 2200 milliamp hour, and it is 3.7 volts. That's low. Fully charged 4.2 volts. This is one I've taken out of a power bank that I butchered for another project. It was very similar type of power bank to one of these juice banks or power banks. If I pop the back off these, you can pick these things up for like £2.99, even cheaper actually. And inside you have a 18650 cell and a little buck converter there that converts the 3.7 volts here up to 5 volts in order to charge your phone. And it also has a little charge circuit that keeps this cell safe. Little disclaimer, you should do lots of research into the health and safety regarding using these lithium polymer batteries. They can explode if overcharged, mistreated, overheated, over discharged and all the rest of it. So I'm going to be using protection circuits in this circuit that we're going to build. So don't take any shortcuts and skip those. At the moment this cell doesn't have any protection, but we'll add those in. This is the buck charger I'll be using, or the buck converter. This one's actually salvaged from another power bank where the batteries had just stopped charging. I identified that it was the battery that was faulty, so I've cut the converter board out. This one's quite nice because if I double press that I get a little light, so it's actually got a little built-in torch. If I singular press it, we get some LEDs here. 4 LEDs indicate how full the battery is. So that will be connected to there. Now what I could do is, the buck converter does have a charge port on it, so I could charge the battery through this, but what I find happens is when you start to charge the battery you can no longer take charge out. So it's a one or the other type device. You can't do both at the same time. If you can find a board or a circuit that does both at the same time, you may only need one circuit. But that's what we need. It is a buck converter. And what does that do? That takes 3.7 volts to 5 volts. Another piece I'm going to be using is the charge controller PCB. So this is a LiPo protection circuit. Now depending if you're using 1 cell, 2 cells or 3 cells, you can get different boards. If you're using a 2 or 3 cell board, it'll actually have a smart charger in there that will do balanced charging. This circuit will protect the battery from being over discharged. It doesn't necessarily do an overcharge current, because it might say cut off at 5 amps and that might be too much for your cell. So you should try and balance what power's going in. The other thing it will do is it's got short circuit protection, so if there's a short circuit it will just disconnect the battery until you remove the short circuit connection. I think they may even stay shut down until you apply some charge voltage to this. So what we're going to do is we're going to connect the solar panel to the LiPo protection circuit to charge. We'll connect that of course to the battery. We'll connect the battery to this buck converter, and then the buck converter to the amplifier, and the amplifier will go to some speakers. I have some speakers that I'm going to use. I'm also going to add this Bluetooth module. So here's a Bluetooth module. Now some other things I do need, which I don't have here, is some sort of enclosure. I didn't really want to have to custom make the enclosure from wood and stuff. I may do that, but I was thinking I'll just take a quick trip down the local DIY store and see if I can find any kind of boxes or enclosure that might be suitable to house this in. This is what I got. A little kind of plastic or bits and bobs container. So it's got these compartments. I didn't notice it didn't actually come with the dividers. I could have probably got a discount for that. But actually I'm going to cut these bits out anyway, so that doesn't really matter. I was thinking of a metal box. I had some bigger speakers that I might have used. These, I can't remember what they are, Bush speakers or something like that. But they're quite bulky actually. I did design these speakers. I designed these using Tinkercad. Recycled these out, some old, what were these speakers? Some other speakers that were being scrapped. And this one's got a nice little kind of driver down here. And this is just kind of like a little bass port. It doesn't actually have any drive to it. It actually works on the pressure built from this one going in and out. And that one makes that one go in and out. Now, I 3D printed all of the bits of this. Let me get that one out of the way. So the front plate and this part here with an angle on it, and then I was going to put a back on here, but I actually found that a very difficult shape to 3D print because it's just a flat piece with a curve. The idea was I was going to cut a piece of alley plate and fold that and put that on, but actually what I ended up doing was just using some of this foam board, and that's worked quite well. Hot glued it around the back. I know it doesn't look great compared to the rest of it. The rest of it looks not too bad, if you don't mind me saying, but that actually is functional. And the idea I've got is to cut a hole in the front of here and another one up the other end, slot these in, they'll be sunk down into the box as far as they'll go, and they'll just stick out the front, and they're nice little contained units with this back piece hidden away inside the box there. Now the other thing I was going to do, I got one of these, I believe it's tobacco tin. They were quite cheap. I could have folded up a little metal box, but to save some time, this is a nice little box. There's no plastic or anything inside, it's all metal. What I'll do is actually put the lithium polymer batteries in there, and that's just a little extra safety feature in case, you know, one of them decides to blow up. I might actually put a few in there. I could fit 3 or 4, I reckon. So that's the tin I'm going to use. I will put a little screw in each end, drill some holes for the power wires to go in. Essentially attack the hell out of this container with the rotary handy tool. Nice little cutting disc around there. Yeah, the speakers should fit in there quite nicely. Well, that one goes in. Sits down nice and flush. I'll probably glue that in with some runny glue, no more nails, something like that. Does it go in with the back in? I did measure it for both of those. A bit tight, but better to be tight. Will that one go in? Yeah. Does the tin go in? Should have put that in when I had one speaker out. The tin will fit in there. And I still have this room up here for the electronics to go in. What I'm going to do with the solar panel is 3D print something. I've got to 3D print something really. So a little bracket that goes on the back here that holds this, and with a clip and maybe some friction hinges, so that tilts out and it will sit like that, and you can have that adjustable. What else did I do? Put some holes in the tin because we're going to use this as our battery pack. I'm going to put a little rubber grommet in here. That's just to stop any of the wires, if they move or rattle, from cutting. Will that fit in there? Took a little bit of working, but the grommet is in there now. Beauts. Next I want some little screws to kind of screw that lid on. Can never have enough screws. What size screw are we going to need? We also need a driver. Where's the driver coming from? These cells here are about 3.7 volts. So they're basically flat 3.7 volts. This one that I've had lying around for some time now is 2.9 volts. It's just on the threshold of what's safe, really. Much lower than that, it's not really recoverable. People would argue on that, but it's quite low. I just pulled one of the tabs off the end of that. It wasn't very well welded on there. Probably use some of these. These are some Samsung ones out of a laptop battery. We'll set the charger up to do 1S, one cell. There are 2 cells there, but they're technically only one because they're both connected in parallel. We'll connect positive on. Can I get negative around there? Sorry, it's a jumble of wires here, but I keep them all together like this. Yeah, I can tuck that in down there. Press charge. It's seen them and they're charging. Now they've jumped up incredibly quickly. 4.02. Oh, they're sitting there. So we'll leave that one charging and see just how much capacity there is. I think I've decided I'm going to mount this little buck converter externally here with the LEDs facing up through this plastic and the little button there. That way I can just kind of press the button, see how much power is left. I did mark that, but whether or not I'm going to do an accurate drill here is another story. What do I need for that? Well, that was a 2mm hole, so I need some little M2 nuts and bolts. My trusty step drill. There we go. It's perfect. That cuts that really nicely, leaves no swarf behind. Battery, if I take the power supply down, it does update. Cracked the back of that off, soldered some fly leads onto the USB port inside the Bluetooth module. Hot glue is a go, just line that up there. To get the 5V feed off this USB port, I did have to take that board out again, run some fly leads off the back of that USB port, double check the polarities because I don't want to go blowing everything up. Splendid, it all fits together nicely. Got both the speakers wired up. They're just in there for testing purposes at the moment. Just see that the system works. The Bluetooth module fell down, but it will go back in there. So I've got that wired up now. It's drawing about 85 milliamps. Oh, what's happened there then? Overloaded something then. Doing a bit of bench testing has yielded some problems. So when this is powering the amplifier and the USB module, the little buck converter down here, the kind of ripple, however much I try to stabilize it on the power rail, causes this Bluetooth module to drop out. Now I did actually find that the Bluetooth module will run off 3.3 volts. So I think it said 3.7 volts. I've actually tapped inside there to the 3.7 volt rail, and I'm going to run that straight from the battery via its own little PCB protection circuit, and then use this buck converter to buck up the voltage from 3.7 to 5 volts for the amplifier. We'll now make our little battery container here. I'm going to run the wires to the buck converter in. We'll now add the PCB protection circuit. So there you have it, a fully contained battery powered stereo. There is some additional things I need to do. I haven't fitted the solar panel yet. I'm going to have to do some designs on CAD and fit the panel on the back there, but the circuitry is all there ready just to take the solar panel feed. The Bluetooth module is fed straight from the LiPo protection circuit. The 5 volt buck converter is powered through itself. That's all connected up. They need to be glued in, but it should be ready. Well, I think that's it for today. What I'll do is make a follow-up video where I put the solar panel on. I've got some other ideas. I would like to put some like USB ports here so I can actually charge a mobile phone or tablet from the device, from this unit. Maybe even have a USB to charge the battery as well, so if we don't get enough sunlight I can actually use it as a portable power bank. And I'd also really like to add that LED. Still not sure whether I'll go with that LED. I was thinking maybe I could make some sort of add-on here or there, or I'm not really sure what I could do with that. Maybe that could work, and it'd be a little lamp. Not sure. I was also thinking I could put some red, green, blue LEDs around here and actually have some patterns going on, but they would sap my battery pretty quick. But why not? Let's jazz that right up.